Good afternoon, students. Today, let me learn about the topic solutions. We know how to prepare the solution. Solute plus solvent gives solution. Example, sugar solution. Water mixed with sugar. You will get the sugar solution. Water is a solvent, sugar is a solute. Sugar solution is a solution. Seawater is one of the naturally existing solutions. Seawater is one of the naturally existing solution. It contains many dissolved salt, mostly sodium chloride. We know that seawater is salty taste because it contains sodium chloride salt. Another important naturally occurring solution is air. Air is an homogeneous mixture of nitrogen, oxygen, carbon dioxide and other traces of gases. So air is a homogeneous mixture. It contains nitrogen gas, oxygen gas, carbon dioxide and other all the things are gases. So it is a homogeneous. Then even solid materials such as brass is a homogeneous mixture of copper and zinc. Copper is a metal solid. Zinc is a metal solid. Copper and zinc mixing we will get brass. Brass is an alloy. That solid material also a homogeneous mixture. Next, let me learn about types of solutions. A solution is a homogeneous mixture of two or more substances consisting atoms, ions or molecule. A solution is a homogeneous mixture of two or more substances consisting atoms, ions or molecule. The compound that is present in large amount in a homogeneous mixture is called solvent. In a homogeneous mixture, the large amount of the substance is solvent and other substance is solute. Example, in a small amount of sodium chloride is a salt that is dissolved in water. A homogeneous solution is obtained, salty solution obtained. In this solution, Na plus and Cl minus ions are uniformly distributed in water. Here water is the solvent. The amount of water more compared to amount of sodium chloride present in this solution. The sodium chloride is the solute. Solute or solvent can be in any of three states of matter. Solute and solvent, any three states of matter, that is solid or liquid or gas. If the water is used as a solvent, the resultant solution is called an aqueous solution. So what is meant by aqueous solution? If the water is used as a solvent, that solution, the resultant solution is called aqueous solution. If the solvent other than water used as a solvent, the resultant solution is non-aqueous solution. Have you understood? The water is used as a solvent. The resultant solution is called aqueous solution. If solvent other than the water is used, then the resultant solution is called non-aqueous solution. So water, we know water is a solvent. Other than the water solvent is benzene, carbon tetrachloride. Benzene, carbon tetrachloride, ether, etc. So next one, types and examples of solution. So three types of solution. First one, gaseous solution. Second one, liquid solution. Third one, solid solution. Three types of solution: gaseous solution, liquid solution, solid solution. Okay. So gaseous solution, they split into solute and solvent. So solute is gas, solvent also gas. Example, air. Okay. So that solute is liquid, solvent is gas. That is humid oxygen, oxygen containing water. The next third type, solid solute, solvent is gas. Camber in nitrogen gas. Example. The next second type is liquid solution. The first one, gas in liquid. That is example is carbon dioxide dissolved in water, carbonated water. Second one, liquid dissolved in liquid. That is ethanol. Then solid and liquid. That is salt water, sodium chloride and water. Third type is solid solution. Okay, solid is a solvent. Here liquid solution means liquid is a solvent. Gaseous solution, we are taking gas as a solvent. Here gas in solid, solution in of hydrogen in palladium. Okay, so hydrogen gas, they are mixing in palladium. So the next liquid in solid, amalgam of potassium used for dental filling, dental clinic. So next one, solid, gold alloy of copper used in making jewels, making copper mixed with gold. Next one, expressing concentration of solution. In our life, we come across many solutions of varying strength and concentration, such as mouthwash, antiseptic solution. We know the solutions are mouthwash solution, antiseptic solution, house coat disinfectants. So these all that materials having different concentration. The concentration of a solution gives the amount of solute present in a given quantity of solvent. The concentration of a solution gives the amount of solute present in given quantity of solvent. Now we will study different concentration unit and their illustration. So the first one is molarity. Molality denoted by M. This is the definition. Okay, so molality is defined as a ratio of number of moles of solute to the mass of the solvent. Molality is defined as the ratio of number of moles of solute divided by mass of the solvent. Molality denoted by M. The second one is molarity. Molarity denoted by capital M. Molarity is defined as the number of moles of solute divided by volume of solution. Volume of solution represented by a liter. Here mass of the solvent. The third one is normality denoted by capital N. Normality is defined as number of gram equivalent of solute divided by volume of solution. So molality, see the problem, how to calculate the molality. The molality of the solution containing 45 gram of glucose dissolved in 2 kilogram of water. Okay, given that molality 45 gram of glucose is given. Okay, so number of moles of solute divided by mass of the solvent, that is formula. So number of moles of solute here, that is solute is glucose. Glucose formula C6H12O6, that molecular mass is 180. So 45 divided by 180 by 2 kg, so 2. Second one, you want to calculate the molarity. 5.845 gram of sodium chloride dissolved in water and the solution was made up to 500 milliliter using a standard flask. The strength of the solution of molarity. Molarity formula, number of moles of solid divided by volume of solution. Here number of moles of solute is sodium chloride. So that it gram 58 5.845. Okay, so divided by volume of solution. Here 500 milliliter is given. 500 milliliter is converted into liter, 0.5 liter. Okay, so like that problems are given. So the next one is formality. Formality F. Formality is defined as the ratio of number of formula weight of solute divided by volume of solution. Formality is defined as ratio of number of formula weight of solute divided by volume of solution. So the next one is mole fraction denoted by X. The number of moles of component divided by total number of moles of all the components present in the solution. Consider a solution containing two components A and B whose mole fraction are XA and XB. Mole fraction is XA and XB respectively. Let the number of moles of the two components A and B be NA and NB is the number of moles of the components. So XA equal to NA divided by NA plus NB. XB equal to NB divided by NA plus NB. So you can add this both XA and XB. You will get NA divided by NA plus NB plus NB by NA plus NB. So that is equal to 1. So the next one is mass percentage. Weight bar weight. Percentage of weight bar weight. So it is defined as mass of the solute to the mass of the solution into 100. Percentage means into 100. So listen, these all questions are 2 mark question. Define molality, define molarity, define normality. So in this expression itself you want to learn the definition. How to learn the definition? Now first one, molality. Molality is defined as the ratio of number of moles of solute to the mass of the solvent. Like that every definition should study. So the next one, volume percentage, V bar V. So volume of the solute to the volume of the solution. Volume of the solute, the ratio of volume of the solute to the volume of the solution is called volume. So percentage means into 100, multiply by 100. The next one is mass by volume. Mass by volume means mass W, volume V. So M bar V. So mass of the solute divided by volume of solution into 100. Next, parts per million. Parts per million, ppm. So ppm is defined as number of parts of the component divided by total number of the parts of all component into 10 power 6, or mass of the solute divided by mass of the solution into 10 power 6. Okay. In complexometric titration involving EDTA reaction between EDTA and the metal ion take place in the 1:1 mole ratio, and hence the molar solution are used in the titration. Okay, so this complexometric titrations, the solution molarity, formality, normality we can calculate in complexometric titrations. That complexometric titration means a redox reaction take place. We use normality. The mole fraction is used to calculate the partial pressure of gases and vapor pressure of the solution. The mole fraction is Mole fraction is used to calculate partial pressure of gas and vapor pressure of gas. Okay. ppm already studied. What ppm means? Parts per million. It is used to express the quantity of solute present in small amount of solution. It is used to express quantity, measurement, okay, quantity of solute present in small amount of the solution. So next let we learn about standard solution and working standard. Standard solution means known value. That solution we known the measurement. Okay, so known value. Working standard means we will add water, diluted that solution. Okay, so a standard solution, other name stock solution. A standard solution of required concentration can be prepared by dissolving required amount of solute in a suitable amount of solvent. Okay, so the standard solution or a stock solution is a solution whose concentration is accurately known. We know the concentration value. A standard solution or required concentration can be prepared by dissolving required amount of solute in a suitable amount of solvent. That is called standard solution. Okay, so working standard means the solution with the required concentration is prepared by diluting the stock solution. We know the concentration of stock solution. When we dilute that is stock solution, dilute means then also add the water. This diluted solution is called working standard. The necessary volume of the stock solution and the final volume can be calculated using the formula CS Vs equal to Cw Vw. Cs and Vs are concentration of the volume of the stock solution. Cw and Vw are the concentration and volume of the working standard. Next, advantages of using standard solution. The error due to weighing the solute can be minimized by using concentrated stock solution that requires large quantity of solute. Okay, so the error due to weighing the solute can be minimized. That using the standard solution means we can avoid error due to weighing that solutions to measure. Okay, so we can prepare working standard of different concentration by diluting the stock solution, which is more efficient since consistency is maintained. We can prepare more working standard of different concentration by diluting the stock solution. Stock solution means standard solution means we know the concentration. Then diluted that is stock solution means we will get different concentration. Some of the concentrated solution are more stable and are less likely to support microbial growth than working standard used in the experiment. So that concentrated solution are more stable or less stable. It is likely to support microbial growth than working standard. Okay, so that concentrated solution are more stable, but that working standard support microbial growth.